In your notebook, write today's date 7.1, solve linear systems by graphing. You can solve systems of equations by graphing, by substitution, or by elimination. Either three of these methods will give you the same answer. So you are going to solve systems by graphing today. Now look at this question and write the two equations. X plus y equals -2 and 7x minus 4y equals 8. Copy these two equations. The question is asking you which ordered pair is a solution of the linear system. So what you're going to do is you're going to use the backward strategy. You're going to work backwards from the answer choices given. You're going to assume and you're going to try answer choice A. So try choice A, which is -2, 0. So the first one is your x, the second one is your y. You're going to take x and y and you're going to substitute in the first equation. X plus y equals -2. And the second equation, 7x minus 4y equals 8. So when I substitute in the first equation, my x is going to take on -2 plus 0 equals -2. When I try to solve this, -2 is equal to -2. So this becomes true. Now when I substitute the same point in my second equation, so 7 times -2 minus 4 times 0 equals 8. Replace your x by -2 and your y by 0. So 7 times -2 is going to give me -14 minus 0. 4 times 0 is 0 equals 8. And in this case, I'm getting -14 is equal to 8, which is false. So since it only works for one equation and it does not work for the second one, answer choice A is out. Now let's try answer choice B. So answer choice B is giving me 0 and -2. So the first one is my x, the second one is my y. So I'm going to go for my first equation, replace x by 0 and my y by -2 equals -2. -2 is equal to -2, which is true. And now I'm going for my second equation, 7 times my x is a 0 minus 4 times my y is a -2 equals 8. 7 times 0 is 0. -4 times -2 is positive 8 equals 8. 8 is equal to 8, and this is also true. So this point works for the first equation and for the second equation. So therefore my answer choice in this case is B. Now let's focus on question number 10. This question, you are given a graph. You want to find if the solution given by the graph will work for this equation. So when you look at the graph, you're looking at the point where the two graphs intersect. The point of intersection is actually the solution. So you're looking at 1, 2, 3, so 1, 2. So this point is actually 3, 2. So 3, 2 is the solution. So if you want to double check to see whether this is actually the solution for these two equations, you're going to go back to those two equations. So you're going to have x plus y equals 5. And in this equation, I'm going to replace 3 and 2 for my x and y. So my x takes on 3, my y takes on 2. So 5 is equal to 5. So it becomes true for my first equation. So my first equation, it works. So now I'm going to go for my second equation. My second equation is -2x plus y equals -4. So -2 times my x is a 3 and my y is a 2. So I'm trying to solve this. And that becomes -6 plus 2. So which gives me -4 is equal to -4. And in this case also it is true. So since it also is true, it also works on my second equation. So therefore, 3, 2 is the solution of these two equations drawn graphically. Let's focus on question number 15. Now, one way to solve this question, to solve the system of equations, is by graphing. So what I'm going to do is I'm going to graph my first equation and I'm going to graph my second equation. So I'm taking my first equation. I'm going to call this as equation number 1 and this is my equation number 2. Take equation number 1. So you got x minus y equals 2. I'm going to use the x-intercept and the y-intercept. So I'm going to substitute 0, find y, and I'm going to substitute 0 for y, find x. So find the x-intercept and the y-intercept. So when I substitute my x as 0, it's going to become 0 minus y is equal to 2. So minus y is equal to 2. So y is equal to negative 2. So it's going to give me negative 2. And if I want to find my y-intercept, which is when my x is a 0, so now I'm finding the other one and replacing my y as 0. So x minus 0 is equal to 2. So x is equal to 2. So I'm getting my 2 points, 0, negative 2, and 2, comma 0. So my first equation, I'm going to go to the graph, and I'm going to graph them. So I got 0, negative 2, and 2, comma 0. So let me graph the first one. So 0, negative 2 is this, and 2, 0 is this. So I'm going to use a line, and I'm going to graph my first equation. And I'm going to extend this line all the way across. And since it is a line, the line can go on forever in both the directions. So this is my first equation, which is x minus y equals 2. Now let's go for the second equation. Now let's take equation number 2. X plus y equals negative 8. And now I'm going to find my x-intercept and my y-intercept. My x-intercept is when my y is a 0. My y-intercept is when my x becomes a 0. So I'm going to find 2 points using the x-intercept and the y-intercept. So I'm going to replace my x as 0. So 0 plus y is equal to negative 8. So y is equal to negative 8. So I'm going to replace my here. And now I'm going to taking the first same equation. And in this case, I'm going to substitute my y as 0. So x plus 0 is equal to negative 8. X is equal to negative 8. So this point gives me negative 8. So now I'm going to go back to the same graph. 0, negative 8. And negative 8, comma 0. So on your graph paper, on the same graph, now I'm going to graph these 2 points. I'm going to use red. So 0, negative 8. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And this is my 0, negative 8. And my second point is negative 8, comma 0. So 1, 2, 3, 4, 5, 6, 7, 8, negative 8, comma 0. Once I get my 2 points, I'm going to connect them. And I'm going to connect them. And once I'm done connecting them, I'm trying to see where the 2 lines overlap. And the 2 lines actually meet or intersect at this point. So this is a point of intersection. So this point is actually the solution. So if you try to find the solution, in this case, the answer will be negative 1, negative 2, negative 3. So it's going to be negative 3, comma, 1, 2, 3, 4, 5, which is negative 5. So this is a solution for the two systems of the system of equations. So this is going to be negative 3 and 1, 2, 3, 4, 5, negative 5, which is the answer. Write this down. Consistent independent system always have one solution, and more will be described in the next lesson. So write this one statement. So consistent, independent system always will have one solution.